Hello everyone. Today we will learn about 30 60 90 triangle theorem. We will learn the theorem with the proof. Before starting the theorem, first we will understand what is a 30 60 90 triangle. See, 30 60 90 degree triangle. Okay. So first we will see what is 30 60 90 triangle. See, here triangle ABC is a right angled triangle. Okay. In triangle ABC, angle B is 90 degree. That means angle B is a right angle. And the other two angles are acute angles. And see, the measure of this angle A is 60 degree and this measure of this angle C is 30 degree. Okay. So this is the 30 60 90 triangle. See, if we add 30 degree plus 60 degree plus 90 degree, what we will get? 180 degree. Okay. That means this is the sum of measures of angles of a triangle is 180 degree. So this is how a 30 60 90 degree triangle looks like. Okay. Now we will see the theorem related to this triangle. Now we will see the 30 60 90 triangle theorem. This theorem is a lengthy theorem. It has two parts. So we will see the first part in this video and the second part we will see it in the next video. Okay. Now we will see the 30 60 90 triangle theorem part 1. Okay. This is a big theorem. So we will prove this theorem in two parts. Okay. The part 1 of this theorem is, see, theorem. If in the exam it is asked prove 30 60 90 triangle theorem, then you will have to remember the statement also. Okay. So here, see, look at the statement of the theorem. See, if the acute angles of a right angled triangle have measure 30 degree and 60 degree, then the angle of the side opposite to 30 degree angle is half the length of its hypotenuse. Now I will explain this. See here, just now we have seen what is 30 60 90 triangle. So here triangle ABC is a 30 60 90 triangle. So this means what? In a 30 60 90 triangle theorem, the side opposite to 30 degree, that is the side opposite to 30 degree, that is this side AB, the length of this side AB will be half the length of the hypotenuse. Now hypotenuse is this side. Okay. So this means what? This side AB will be half of this side AC. Okay. That we have to prove. Now next we will write the given part. Okay. Now from the statement we have to write the given part. So what is given? See, after if, whatever the part of the statement is there till here, till then, from if to then, the part of statement between if and then, this part of the statement is given. Okay, see. So here what is given? See, the given part is, if the acute angles of a right angled triangle has measures 30 degree and 60 degree. Okay, see, till here, this much part is the given part. Okay, so how you will write the given? See, the given is what? Only this much part is given, that triangle ABC is a right angle triangle with measure of the acute angles are 30 degree and 60 degree. That is given in the statement. Now this you will write it like this. Okay, in triangle ABC, angle B is 90 degree. Okay, see, angle C is 30 degree, that is it is here, and angle A is 60 degree here. Okay, so this much part is only given. Now you have to write to prove. Okay, so after then, see this statement, after then whatever part of the statement is there, that we have to prove. Okay, then के बाद जो भी है statement में वो हमें prove करना है. So what we have to prove? The length of the side opposite to 30 degree angle is half the length of the hypotenuse. Okay, so this means how you will write? See, the length of the side opposite to 30 degree angle. See, 30 degree angle is this. Okay, the opposite side of 30 degree angle is this side. Okay, side AB is opposite to this 30 degree angle. Okay, the length of the side opposite to 30 degree angle is half the length of hypotenuse. Hypotenuse is this side. Okay, so what we have to prove? So here we have to prove AB, that is this side AB is equal to half AC. AC is the hypotenuse. Okay, that you have to prove. So AB is equal to half AC. See here, this you have to prove. Okay. So this is how from the statement we have to write given and to prove. Okay. Now see the construction. See here we cannot prove the theorem directly. Okay. From this given figure, we cannot prove the theorem directly. So what we will do, we will add something in this figure. So that is called construction. Okay. See, while proving a theorem, if you are adding something in the given figure, then it is called as a construction. Okay. So here what we have to do, so the construction, take a point D on the extended segment AB such that AB is equal to BD. See, I will explain. See, extended segment. So this segment is there, no? This segment AB. Okay. Extended segment AB, right? So this segment AB is there, that you have to extend. Okay. This segment AB that you have to extend, and here we will write a point D. Okay. See, I will show you. The segment AB, if we can extend it, okay, like this. Okay, this AB I have extended it here and take a point D. Okay, so we have to take a point D on the extended segment AB such that AB is equal to BD. Okay, this AB, this length of this side AB, see here, AB is there, no? The length of the side AB should be equal to the length of the side BD, this. Okay, this length and this length should be equal. Okay, AB is equal to BD. Okay, then what we have to do, draw segment DC. Okay, see here, C is here and D is here, point D is here. So we have to connect this and draw segment DC. Okay, understood? Point D and C have to join. Okay, so this is the construction. This part we have drawn it extra. Okay, it was not given in the figure. Okay, ये पहले नहीं दिया था, ये हमने extra draw किया है for proving this theorem. Okay, so it is called as a construction. Okay, so I will show this properly. See, this is the construction. I have drawn it properly. Okay, take a point D. We have taken a point D on the extended segment AB such that, see, this AB is equal to BD. Okay, and draw segment DC. Okay, so this is how we have to do the construction. Now next we will see the proof of this theorem. Now the proof, see here we are getting two triangles. Okay, now consider these two triangles. First we will consider triangle ABC. Okay, and the next triangle DBC. Okay, so here triangle ABC and triangle DBC. These two triangles you have to consider. Okay. Now next, so what we will do, we will prove these two triangles are congruent. Okay. ये जो दो triangles है इसको हम पहले congruent prove करेंगे. Okay. Now these are the steps. Now I will explain each step one by one. Okay. See here, segment AB is congruent to segment DB. Okay. See, segment AB, this is congruent to segment DB. Okay, this. Now the reason for this is, so the reason for this step is construction. See here. By construction we are getting this segment AB is equal to segment DB. So after each step we have to write the reason. See, while proving a theorem, for each step in this proof we have to write the reason. Uska reason kya hai? Why it is congruent? See, we have done the construction in such a way that AB is congruent to DB. Segment AB is congruent to segment DB. So the reason for this step is by construction. Now the next step is, see this step. Angle ABC is congruent to angle DBC. Okay. So this angle ABC, this angle. Okay, this angle is congruent to angle DBC. DBC is this angle. Okay. So these two angles are congruent. Why? See, because now the reason for this step is each 90 degree. Okay, see here. This angle ABC and DBC. Okay, see. ABC is 90 degree and DBC is also 90 degree. How? See, when we did construction, we extended this in a straight line, right? The same line AB we have extended. Okay, see. segment AB is extended segment AB. On AB only we have extended the segment and we have taken the point D. Okay, so this AD is a straight line. Okay, see, angle ABC is 90 degree. That means segment BC is perpendicular to segment AD. Then angle DBC is also 90 degree, right? So each angle is 90 degree. Therefore, these two angles are congruent. Okay. Now the next step, segment BC is congruent to segment BC. Okay. See, segment BC is this segment. Okay. See, it is there in both the triangle. Okay. Segment BC is the part of this triangle. Triangle ABC. This triangle also and this triangle also. Okay. Okay. The reason for this step is common side. Okay. This side BC is the common side in both the triangles. Okay. So it is congruent. So this is the reason. Now the next step. So from this what we are getting? See here side is congruent, angle is congruent and side is congruent. Okay. So therefore these two triangles, that is triangle ABC is congruent to triangle DBC. Okay. The reason is, now it is congruent by which test? It is congruent by SAS test. Okay. That is side angle side. See here. Side angle side. SAS test. Okay. See. These two sides are congruent. Then this angle is also congruent and this side is congruent. So it is both the triangles are congruent by SAS test. Okay. Okay, so both these triangles are congruent by SAS test. Okay, so till here we have proved that both the triangles are congruent. Now the next step is, therefore angle BAC is congruent to angle BDC. Which angle? See here, BAC, this angle. Okay, this angle BAC is congruent to angle BDC. BDC, this angle. BDC, this angle. Okay, these two angles are congruent. That is angle A and angle D. Okay, angle A and angle D. See here. Now, why it is congruent? See, when two triangles are congruent, then the corresponding angles are also congruent. We know this. Okay, जब दो triangles congruent होंगे, उसके जो corresponding angles हैं, वो congruent होगा. Okay, the reason for this is CACT, that is corresponding angles of congruent triangles. Okay, see, first we have proved that these two triangles are congruent. Okay, here we have proved, see in this step, we have proved the two triangles are congruent. So, these two angles are corresponding angles. Okay, these both angles are corresponding angles. So, if two triangles are congruent, then the corresponding angles are also congruent. So, CACT, the full form of CACT is CACT. This means corresponding angles of congruent triangles. Okay, CACT. We can write it in short form also. Okay, this is the meaning. Angle A is congruent to angle D. Okay, see this. These two angles are congruent. I have marked it with red color. So, the reason for this is CACT. That means corresponding angles of congruent triangles. Okay, I will continue this proof in the next page. Okay, because we cannot solve the entire proof in this page. I will continue the proof in the next page. Here I will copy this diagram. Now we will continue the proof in triangle ADC. So we have to consider this full triangle this full triangle ADC. Okay, in triangle ADC, angle BAC is equal to 60 degree. Okay, angle BAC, this angle. Okay, it is given. It is already given that this angle A is 60 degree. Okay, therefore angle BDC is also 60 degree. See, from here what we have got, see this, angle BAC is equal to angle BDC. Okay, so here BAC is equal to 60 degree. That means BDC will be also equal to 60 degree. Okay, BDC is this angle. BDC, this angle will be also equal to 60 degree. So, therefore, the next step, angle DAC is equal to angle ADC is equal to angles ACD. Okay, so all these three angles, see, These two angles are 60 degree. That we already got. So this angle. So see, now this full angle, that is angle ACD, this angle, that will be how much? That will be also 60 degree. This full angle will be also 60 degree. Why? Because see, this angle plus this angle is how much in this triangle ADC? This angle A is 60 plus angle D is 60. So which is equal to 120. Okay, 120 degree. Now the sum of measures of angles of a triangle is how much? 180 degrees. Okay, so 180 degree minus, see, if we add all the angles of a triangle, then we should get the sum of measures as 180 degree. But here we have 60 plus 60. What we got? 120. So 180 minus 120 degree, which is equal to how much? 60 degree. Okay. So this angle will be how much? 60 degree. Angle ACD will be also 60 degree. So in this step, angle DAC equal to angle ADC equal to angle ACD. This ACD. This angle is equal to how much? 60 degree. All these angles are 60 degree. Okay. So the reason for this is since see, this is the symbol for since. Okay. Since sum of angles of a triangle ADC is equal to how much? 180 degree. Okay. Just now I have shown the calculation. Now the next step will be, now what we are getting, the next step is, therefore triangle ADC is an equilateral triangle. Okay. See, if all angles are equal, then the triangle is an equilateral triangle. Okay, because this is the property of equilateral triangle. Okay, equilateral triangle means what? A triangle in which all sides are equal. Okay, in equilateral triangle all the angles are also equal. See here, all angles are 60 degree. Okay, so this triangle ABC, this full triangle is an equilateral triangle because all angles have equal measure. Okay, therefore AC is equal to AD is equal to DC. So therefore AC is equal to AD, this side, equal to DC. Okay. Okay, see here. Therefore AC is equal to AD is equal to DC. Okay. Because here what we have got, all the angles are equal. So the triangle is equilateral triangle. So all the sides are also equal. This is the property of equilateral triangle. See, if three angles of a triangle are congruent, then its three sides also are congruent. Okay, this is a property. So, if three angles of a triangle are congruent, then all the three sides of the triangle are also congruent. This is the property of equilateral triangle. We can prove this theorem also. If you want, I can give the proof in a separate video. Okay, this is the property we are using here. Okay, so therefore all these three sides are equal in this triangle. Okay, see, in this full triangle ADC, all three sides are equal. Okay, now the next step, but AB is equal to half AD. Okay, AB is equal to half AD. Now see, AB is this side. Okay, this side is half of this full side. Okay, this full side, it is a half of this side. AB is equal to half AD. Why? Because of our construction. See, in construction what we have taken, this AB is equal to BD, right? This AB is equal to BD, right? So this AB will be what? Half of AD. Okay, AB will be half of AD. So the reason for this step is by construction. Side AB is equal to half AD. This we are getting it by construction. Now the next step is, therefore AB is equal to half AC. Okay. See, instead of AD, we are writing here AC. Here AB is equal to half AD is there, no? Now here what we got, see, AD is equal to AC. Okay. So instead of AD, you can write AC. Okay. Instead of AD, you can write AC. So AB is equal to half AC. The reason for this is since AD is equal to AC. Okay. See, this is what we have to prove. Okay. AB is equal to half AC. This is what we have to prove. So see, here we got the answer. AB is equal to half AC. This is what we have to prove. Okay. Understood? This is the theorem. First part of the theorem. So we have proved this theorem. So here we end the part 1 of this theorem. The part 2 of this theorem we will see in the next video. If you have any doubt in this topic, please write it in the comments. If this video was useful to you, then please like and share it, and don't forget to subscribe to my channel. Thank you for watching.